Um, Welcome, everyone. Timon gave a great introduction to Cord. So one of the verticals of Cord is the transformation for the mobile network. And that we coin it as M-Cord. So let me start with the business proposition. So there's a big problem with telco networks today. Between now and 2022, we expect the mobile network traffic to grow over eightfold. And about 75% of this traffic is going to be due to video. And really, when we think about it, new devices, new access technologies, and cloud adoption, they're all driving this. But the biggest problem is, while there's this healthy traffic growth, the growth in the telco revenues is not catching up. And this is due to the fact that the CapEx and the OpEx requirements to sustain a healthy network to drive this traffic is actually overtaking the potential revenues that telcos can get from the traffic itself. And this is also due to the fact that competitors like OTTs, cloud servers, media servers, etc., are actually taking more and more of the potential revenue from that traffic themselves. And they're doing that without really bearing the brunt of the cost of the network infrastructure itself. So there's a clear need for telco providers to go through a transformation. And for the first thing that needs to happen is that telco operators need to transform their networks to lower their CapEx and OpEx. But hand in hand, they also need to position themselves significantly more deeply into digital services ecosystems. So they will, with that, they will play a more significant role as a broker, if you will, between the competitors that I just mentioned and the end users, so that they can play a more significant part in this revenue share game. But in parallel, they need to actually provide platforms as a service or connectivity as a service for services that Timon mentioned, like IoT, but also with 5G, the new services that are poised to be supported towards end users of today, as well as new verticals that 5G is hoping to attack. And this is where M-Cord really comes into play. So as a platform, it is all about transforming the mobile telco provider's network and also providing a new platform on which new services can be rapidly innovated and deployed. So M-Cord really builds on the pillars of open source: disaggregation, virtualization, cloudification, and programmability. So the whole idea is to come up with a programmable, configurable, orchestratable, and solution on which telco providers can innovate services on. So while the open source and the commodity hardware aspects of the solution will certainly drive down the cost, the real transformative aspect of M-Cord lies in its enablement of new service innovation and deployment, and how rapidly that can take place compared to how it is done today. So at the core of everything really is disaggregation. You guys have all heard about, through the popularity in recent few years of VNF, about virtualization in the core. So we have really come to terms with the fact that in the mobile networks, as far as the core network is concerned, which is EPC and LTE and LVNG core for 5G, we have disaggregated the traditionally vertically integrated devices, and we have virtualized it and disaggregated into components so that they can be independently scaled, and we have moved towards a cloud-native solution in the core. But a real important thing that Timon just talked about is that about 75 to 80% of the expenditures of a mobile service provider is at the edge. And that edge means the wireless link. That's the base station. So M-Cord is spending a significant amount of work towards disaggregating the base stations as well. So here, the disaggregation, the first part is now almost universally accepted in the form of Cloud RAN or centralized RAN, where the base station is disaggregated into two parts, the centralized unit and the disaggregated unit. We are taking that one step further in M-Cord. The centralized unit is also further disaggregated so that we have a clear user plane, control plane separation. But then there's even a further disaggregation where the control plane is also disaggregated further into two, where we look at the RAN and the control functions that reside in it and disaggregate those control functions into functions that are very delay sensitive and functions that are less delay sensitive. And the less delay sensitive aspects, we actually turn them into applications running on an SDN controller. So the disaggregation, virtualization, and SDNization go hand in hand with an M-Cord. And it actually, for the mobile edge, it moves in both directions. So from the base station, we are moving towards the edge cloud by disaggregating and virtualizing what we disaggregate. But from also the core, which traditionally resides at the core network, we are pushing on a use case based solution some of the functionalities to the edge as well. So M-Cord then really builds on Cord. So as such, it is a cloud infrastructure. So it has a leaf spine fabric, and we have commodity hardware running on it, and this is where the virtualized network functions reside. And we also have a suite of controllers that I will get into in the next slide. But what you can see here is clearly the disaggregation on both levels. So from the base station side, some of the functionalities that you see as color-coded are moved towards the edge cloud, and from the core network side, some of the functionalities can be moved to the edge as well. So in M-Cord, as with all other flavors of Cord, really we have a suite of network operating system, if you will, network and services operating system. So here, ONOS is our SDN controller that controls the fabric, but also it controls the virtual network on which the VNFs reside and form programmable service chains. And it also, actually, in addition, directly controls our peripherals, which are the base stations. We have OpenStack today as our cloud manager, but Cord is also extending the options in that arena, and we are also adding containerization in the form of Kubernetes as an alternate solution there. And we have XOS, which is our services operating system. So Timon touched on this a little bit. In Cord, the whole idea is to treat everything as a service. Traditionally, in virtualized networks of today, the services, when we talk about services, these are usually the virtualized network functions. In Cord, yes, we have VNFs as services, but also network control functions as services as well. So if you want to create, for example, a service chain, and let's say a network slice, then Cord treats network slicing as a service as well. And that clearly entails the programmability of both the fabric and the VTN. And if you want to do slicing in the RAN, then that also entails the programmability of the base stations. So Timon gave you a synopsis of the service graph for the R Cord. So this would be the equivalent of that for the M Cord. So here, maybe I should also announce that we have recently open sourced our first open source EPC, first version of the open source EPC. A new version is going to come out at the end of next month, and a more complete solution will be available by the end of the year. And this is going to be release 11/12 open source EPC, and some of the major tier 1 service providers are going to take this to field trials. So from the initial formation, the open source EPC has been designed to be very, very scalable and a production-grade solution. So this is exactly what that is. And as you can see, we have 3 different controllers here. There is some services that are controlled by ONOS, the SDN Controller, some services controlled by OpenStack, and some by Cord itself. So here we have end users in a split RAN architecture passing through the remote unit, which is the antenna element, as well as some processing there, and the cloud unit. And the interesting thing about the cloud unit is it needs to first come out as a VNF, and as such, it needs to be controlled by OpenStack. But once it's up and running, it becomes something that needs to be controlled by ONOS. And then we have the core network, and as you can see, we have also an SDN control service that resides in there that allows the service providers a big network state exposure on which they can develop innovative services. So the SDN controller in M-Cord serves on top of the traditional notion of controlling both the fabric and the virtual network, really three more important things. It is a controller that handles end-to-end network slicing. It is a controller that controls the base station in the form of XRAN, and it is also a controller that controls the data plane at the core network, allowing exposure for the network state for third-party applications. And the XOS, the services operating system, actually is a localized services orchestrator, if you will. It has a GUI that looks like this. And through this GUI, if you want to actually pass beyond automation, you can come up with new service chains quite rapidly and deploy them. So let me also now talk a little bit about the current state within M-Cord. And very recently, at MWC Americas in San Francisco, we had a booth for M-Cord, and we showcased actually 5 distinct demos. So let me go through them very quickly, one by one. The first one was on XRAN. How many of you know the XRAN consortium here? Okay, so very few. So let me first introduce that a little bit. XRAN.org was formed maybe about a year and a half ago or 2 years ago to develop, standardize, and promote a software-defined, extensible radio access network. So here the whole notion is, when you think about it, in base stations we have a lot of control functions. Let's name a few of them. Handoff management, access control, scheduling. So any function within the RAN stack which actually controls how the flow is processed is a control function. So these control functions traditionally have closed loops within 3GPP standards. So for example, once you deploy a network, the handoff configuration is set. So unless you manually change your configurations, every user's device is handled the same way. So there's really no room for innovative, fast, policy-driven handover mechanisms. So what XRAN is trying to do is it is trying to disaggregate a portion of this control plane and then by exposing that, allowing policies as well as the traditional closed-loop 3GPP control to manipulate what is really taking place. So we have shown in the demo 2 distinct examples for this. The first one was a quality of experience-based load balancing by policy-driven handovers. So imagine a scenario where we have 2 end users that are very, very close to one base station. So the traditional 3GPP dictates that the base station that gives you the strongest signal strength is your serving base station, unless a SONA application pushes you away. So here we have 2 users, but these 2 users are both demanding very high data rates. So because of that, they're not really they're not getting their quality of experience as well as they could. So a policy-driven solution would actually allow the SDN controller on which this handover intelligence resides push down rules. And these rules will force that base station to hand over one user to another freer base station, even at the expense of that user having a lower signal quality from that base station. But at the end, you allow more users to have better quality of experience. And again, a policy-based intercell interference cancellation was demoed in San Francisco as well. So here, the whole idea was you have, again, 2 base stations. They happen to have a radio planning such that their carrier frequencies are the same. But this is causing significant interference because both cells are loaded. So a policy-driven solution would programmatically orthogonalize the operational carriers between the 2 base stations so that the interference is mitigated. I talked about the open source EPC. The San Francisco MWC was the place where we actually announced the availability of open source EPC, and furthermore, we demoed that there as well. So the whole idea was to show how scalable it is. So we used our partner NG4T's emulated RAN to populate up to 50,000 users, and a DPDK-supported M cord provided with the open source EPC, very good service for all of these users. Probably Manuel is going to talk about this in much more detail, but DT with Radis also showcased a multi-access cord. So this was a platform, an edge cloud platform, which serves not only the mobile users, but also the residential users that are connected via fiber. So here, on this platform, imagine a scenario where you have a home CPE which has a fiber connection, but with an LTE dongle, it also has LTE connectivity. And that CPE locally can do load balancing between these two access technologies. And these two access technologies reside on the same cloud, so they have the same network operating system suite that controls both. Another important demo in San Francisco was to show that actually an all ARM-based and different switches in use, M-Cord is feasible. One other demo that we did was an end-to-end network slicing control and orchestration, which included the slicing of the radio access network. So here, your resources are the wireless resources. So the solution virtualizes these resources and allocates a subset of them programmatically to a given slice, with associated RAN side control functions. And it is the ONO slicing application that handles that. So for a given slice, we can have its own admission control, its own handoff management suite, its own link aggregation policy, etc., which means you can effectively create virtual base stations out of a single base station hardware. The same application also stitches a given RAN slice to a core network slice by using the base station as an anchor point. And the same application also allows you to programmatically decide how to forward the downlink traffic to an end user using both LTE and Wi-Fi. So that for certain users, you can do complete Wi-Fi offloading. For certain others, you can only use LTE, but for certain ones, you can use both in the form of LAA or LWIP, etc. So that concludes my talk. Thank you. I'll be happy to entertain questions if you have any.
Thank you. We have a few more minutes, so any questions for us? Yes?
Again, congratulations, another great project. So on the RAN side, as you said, 80% of the cost of deploying wireless network is on that side. But also base station is very close to the heart of the suppliers in that domain. So taking all that good stuff and putting it in the controller and making the base station somewhat dumb, business-wise, how are you going to achieve that? Because base station is a core revenue for Nokia, Ericsson, Huawei, and so forth. So I mean, technically I can see it, and I just came from a wireless startup that did that. But business-wise, I can see the service providers benefit. How are you going to convince the suppliers to go that way? I mean, Ericsson just recently opened up a new R&D somewhere in Texas to build ASIC chips for 5G because they're after 100x performance versus going through the x86 route. So that business dilemma, how are you going to handle that?
Excellent question. So that all really is at the heart of this transformation with open source consortia like ONF and XRAN, really. So when you look at, for example, the XRAN.org, there are a lot of different base station vendors that are part of that. The big vendors are not, but the service providers who are part of both XRAN and ONF are pushing those big vendors real hard to make that happen. So there's an internal struggle going on. You're absolutely right. Base stations are where the expenditures are, and that's where the big struggle is. So that is the last big foothold for the incumbent vendors, and that's the last part of this transformation battle. But it is going on right now.
Hi, thanks a lot. Bijan Rufi from Sky UK. It's more of a generic question. With this cord, mobile cord essentially deployments, have you done anything with analytics involved in it? Because I see there is a cord as well. And it would be interesting if you share any sort of pilot or demo that you've done, which analytics involve, basically.
That's an excellent question as well. So a cord is one of the flavors of cord, but having said that, it is complementary to all of the cord flavors itself. So it is part of the platform, if you will. So an A cord enabled M cord is definitely on the works, but there have been some initial demos done on that as well. So specifically, AirHop early on actually incorporated their SON solution with an analytics cord, embedded M cord, for example. Okay. So there have been some demos, but A cord is going through a big enhancement, and with that, and especially with the introduction of the open source EPC and this new network state exposure, I see a lot more things coming in the near future.
Thank you.
Maybe one last question from the audience? No? Oh, one more question. Okay.
So in the previous talk, Timon mentioned that you are trying to provide a car rather than car parts. So are you planning to develop a deployable M-Cord solution, or?
Good question. Well, since we are an open source consortium, it is not in our mission to actually have a hardened commercial solution. So we will provide the framework, and then we expect either incumbent vendors or new systems integrators to take over and harden it and turn it into solutions. Yes.
This is the last question before the next talk.
So you said a lot about building and what is the part of this thing, but I am actually interested a lot about how you're going to agility. For example, you said nothing about how you're going to build it and how you're building software, because from my perspective, this is all about software. So like continuous integration, delivery stuff. So is this somehow also included there, or because you didn't say anything about that, so maybe it will be somehow. So
all of the modern software technology trends we follow at ONF. So yeah, that's a given. That's how the overall framework is architected, and it is continuously being updated. Yes. Every aspect of every component and the overall cord as a platform is handled that way.
Okay, so that's thank you once again, Oguz. Thank you very much.